Hi guys, welcome to Piece of Code and welcome to this video. In this particular video, we are going to continue our OCA crash course series and we are going to continue with a chapter 2. And in this lecture, we are going to see all about looping statements and advanced flow control. So we're going to see the while, do while and for statements. We are going to see the for each statement, which is the enhanced for statement. Then we're going to see advanced flow control concepts like nested loops, optional labels, break statement and continue statement. Okay, alright, so let's start with the first topic, which is the while statement. And if we just have a look at this particular while statement, it's pretty easy to understand. So we have this while keyword over here and then we have a boolean expression, right? So basically if this boolean expression is true, then this body will keep on executing. So what I am saying is, until this particular boolean expression is true, this body will keep on executing. Once this becomes false, we are just going to go out of this loop, right? For example, you are printing numbers from 1 to 10. So you have a variable x and you're going to print the numbers from 1 to 10 till x is less than equals to 10, right? So that will be the condition. Once this particular condition is false, then you are going to go out of that loop, because after that point there will be the number will be greater than 10. Simple example, right, to understand. Let us take another example. Let me go to my editor and let us see another example on the while statement. Very easy to understand, guys, nothing serious about this particular thing. So let me create a class over here in operators and statements package. Let me just create a class over here, a class, and I'm just going to name it as loops, right? Public static void main I need, just going to create it. Here let us, for example, a rat is eating some cheese. So the number of cheeses that I have initially is int number of cheese equals to 5, for example. And so I'm just going to say while number of, this is the number of cheese, right? Number of cheese greater than equals to 0 or greater than 0, right? And then I will say sys out the rat is eating cheese, right? They like cheese, right? So then I'm going to decrement the value of number of cheese minus minus. Now what if you try to guess the output in this case, try to understand what is happening in this particular condition. So this condition says till this number of cheese value is greater than 0, please execute these statements, right? So initially we have the number as 5, so 5 is greater than 0, so this particular statement will get executed, that's fine. And then as the rat has eaten 1 cheese, then we just decrement the number of cheese by 1 over here. Then the number of cheese became 4. Now 4 is also greater than 0. This will get executed then. Likewise, this will keep on executing until the number of cheese value is greater than 0. So you can pause the video and you can also try to find out how many times this system.out.println statement will get executed. Okay, if not, then please continue with the video. I'm going to execute this code and let us see. So it has displayed this statement 5 times as suggested, right? Because first the value is 5, so it is true, printed. Then the value becomes 4, right? It decremented to 4. So when it decremented to 4, it's still true. So basically it will get executed another time. Then it got decremented to 3. It is still true. So then it got executed again. So 3 times executed. Then it decremented to 2, right? 2 is still greater than 0, right? Then executed. Then it got decremented to 1, right? So 1 is still greater than 0. It got executed, right? And then it got decremented to 0. So when it got decremented to 0, now number of cheese value is equals to 0. 0 is not greater than 0, so it became false in this case. This condition became false, so the loop stopped executing. So this is some basic loop concepts, right? I hope you guys know about this. And basically every kind of loop that you see in any programming language kind of works the same way as this thing. So we have a condition, and based on that condition the loop executes. If the particular condition is true, then basically we have the loop executes, and if it is false, then we just go out of the loop, right? That's the thing. Okay, so what happens if this particular condition, this condition that you see, is infinitely true? Let us see an example, right? So here let me write a small code. Let me just remove all these things. Let me write a small code over here, and here let's say we have a int, let's use the black pen. If int x equals to 2, int y equals to 5, while x is less than 10, for example, y plus plus. Now, do you know what is happening in this particular case? In this particular case, if you are seeing this example, this condition is always true. Why? Because 2 is less than 10 and we are not even incrementing the value of x. If we had been incrementing the value of x, then after 8 iterations, x will become 10, right? If we incremented the value of x. But that is not the case, right? We are not incrementing the value of x. We are just saying, okay, x less than 10, then y plus plus, and we do not have any conditions regarding y. So basically what will happen is that this condition is always true, and this piece of statement will keep on incrementing infinitely. So y will get incremented infinitely, right? So this is known as an example of an infinite loop, right? Okay, so that was that's how we can create an infinite loop with while loop, guys. Okay, now let us see some other kind of loops now. Alright guys, let us see the do while loop now. So we saw the while loop, let us see the do while loop right now, and let us understand what is the usage of this do while loop. Now if you see see it clearly, this particular syntax, so it starts with the do keyword, and then we have a pair of curly braces over here, and we have the body over here. But at the end we have the while keyword, and along with that we have the boolean expression, right? And here we need the semicolon. So this is one requirement. So what is happening over here? So if we have some kind of code in this body, right? So we have some kind of code, imagine we have some kind of code, we directly enter into the body, right? We execute the body, and after executing the body, then we are going to go to the end of this particular do block, and then we see a while boolean expression or a condition. So what is happening over here? After executing the body, we are checking the condition. So we are checking the condition on exit. Okay, because if you remember the while loop, so the while loop look like this, right? While condition, and then we used to go inside the loop. So this is checking on entry. So we are checking the condition on entry, but in this case we are checking the condition on exit. So that is why this while loop is known as entry controlled loop, and this particular do while is known as exit controlled loop. Now what is the advantage of do while, or what peculiar thing does do while does when while is an entry controlled loop? So what is the difference? So imagine that initially the condition is false, initially. So when the condition is false initially, in case of a do while loop, we still go inside the body, right? And the body gets executed at least once, because we go inside the body gets evaluated or executed, then at the end when we check the condition, right, it becomes false. Even though the condition is false, we still executed the body once. But that is not the case with the entry controlled structure, which is the while loop. We first check the condition, right? And if the condition is false, we do not go inside the loop at all. So that is the difference between the while and the do while loop. Let us see an example in this case. Let us see an example. Let me go here. and let us try to write a common do while loop which will get executed once even though the condition is false, right? So we have int x equals to 0 for example, and we just say do we for example increment the value of x, all right, and we just say okay, just let's do this much stuff over here, and let's just say while false. We implicitly say that the condition is false from the start, and here we are going to display the value of x. Now try to find out or try to guess the output. Now let us see the code. Now see, the value of x is now 1. Why 1? Because see, there the x value is 0. It goes inside this do block. It gets executed once, so x value is now 1. At the end the condition is checked. When the condition is checked, right, the condition is false in this case. So there will be no repeated executions of this loop. It will only get executed once. Okay. Then we just print the value of x. When we print the value of x, we get it as 1. Now a question may come into your mind, when to use while loop and when to use do while loops. Now in practice it might be difficult to determine when you should use a while loop and when you should use a do while loop, right? The short answer is that it actually does not matter. Any while loop can be converted into a do while loop and vice versa. So it actually doesn't matter which kind of loop you are using. Based on your requirements, you will be using a while loop or a do while loop. So basically it doesn't make any sense. Now let us see an example, and it will make things a little bit clearer. Let us see an example, and let us see the while loop and do while loop side by side, so that you will get a clear picture of what is happening. Okay, so I am going to use this kind of blackboard to write the code. So let us write the while loop on the left side and the do while loop on the right side. So here let us write the while loop. So while x is less than x is greater than 10 for example, and inside here I am just going to do x minus minus, and that is the case. And let us write the do while loop, the equivalent do while loop for that. So I am just going to say if x greater than 10, because do while loop checks it at the end, right? So that might be the case that we first pass the x as 11 and the loop executes at least once. So we don't want that. So let's keep a if condition over here and do, and inside the do we do x minus minus, and then at the end we know the logic while x is greater than 10, and we just get out of the loop, right? That's the whole thing. Now try to understand this scenario. Though one of the loops is certainly easier to read, they are functionally equivalent. It means that both of these loops, right, this while loop and this do while loop, actually do the same job. So Java recommends you to use a while loop when a loop might not be executed at all. If the loop if you have a false condition, and on basis on the false condition you do not want that loop to be executed even at least once, then please go with the while loop. Because see, for that particular thing we have to make this additional if condition over here, right? So why will you use a do while loop if you do not even want to execute it at least once? So the thing is, but determining whether you should use a while loop or do while loop in practice is sometimes about personal preference also, and also about code readability. Now for example, although the first statement that you see in this while loop is shorter, the second has the advantage that you could leverage the existing if then statement and perform some other operation in a new else branch. For example, you can add another else branch over here like this and do a x plus plus over here, but you cannot do that with this particular while loop, right? But you can do this with this particular do while loop, because you have created an extra if condition. So it is basically dependent on your work requirement, right, your logic and your personal preference. So based on all these things, you can either use the while loop or do while loop. Okay, so that was all about the do while loop. Now let us move forward to some other kinds of loops. Okay guys, now let us have a look at this for statement. Okay, now this for statement is also another loop, obviously. Now let us see the syntax of this for statement. We have the for keyword, obviously. Then we have three blocks, you can say, or three sections. One is the initialization section, another one is the Boolean expression section or the condition section, and then we have the update statement section or the updation statement, and then we have the body over here. Now let us see the procedure on which these statements execute, because sometimes the for loop may seem a little bit confusing to many people, because they would think that okay, in every iteration all of these three sections execute at once. Let us see. First, what happens is that the initialization statement executes, and it only happens once when you first go inside the loop. So first the initialization statement executes. Then the Boolean expression, if the Boolean expression is true, then basically continue inside the loop. If the Boolean expression is true, then please go inside the loop. That is what this particular thing means. Then the body executes. Then after the body finishes executing, we go back to the update statement. Some kind of updation happens. For example, you are having a iterator variable, you are doing an I++. And then what you do is you return back to, after executing the update statements or after updating the statement, then just return back to statement number 2. Basically check again if the Boolean expression is true or not. So this is how the thing happens. First of all, when you first enter the loop, the initialization statement executes, then the Boolean expression is checked. Okay, if it is true, go inside the loop, execute the body. After executing the body, update the statement, or if you have any update statement, then execute that, then return back to the Boolean expression. Until this Boolean expression is true, the body will keep on executing. The same stuff as we saw in the while and the do while loop. So that is just the difference between the structure of these loops. Otherwise, the way how all of these loop executes are kind of basically the same thing. Okay. Now let us see some questions or some examples which in the exam you may be tricked upon, right? Now remember that variables declared inside the initialization block of a for loop have limited scope and are only accessible within the for loop. Let us see an example what I am saying. If you have a for loop like this, for int I equals to 0, I less than 10 and I plus plus. Now this may seem easier to you now, but in the exam you may get confused because of the lack of time. Then we have a statement inside this loop which is a simple s.o.pl statement or a system.out.println statement, and we are just printing the value of I plus a space over here. What do you think it is happening over here? So this particular I variable that you see, this iterator variable, it is local to the for loop. As it is local to the for loop, it is only, the scope is only inside this for loop, right? If you are trying to execute this particular, if you try to access this I, this particular variable outside this for loop, like over here, and you just try to execute it here, then it will throw what? It will throw a compiler error, because it is outside of the scope of the for loop, right? That is the thing. Always remember, whatever local variable you declare inside of the for loop, it is going to be inside that scope only. You can only use that particular variable inside the scope of the for loop, right? That is one of the thing. Now if you try to guess the output of this particular loop, excluding this s.o.pl statement, basically it will print the numbers from 0 to 9, right? 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Obviously, because we start with 0 less than 10, that then the particular this condition is evaluated. If it is true, as it is true, we just execute this thing. So 0 gets printed first. Then we go inside the updation statement. Update happens, I plus plus happens, 1 is less than 10 because it goes back to this condition, right? If it is true, body gets executed. Likewise, we get all the numbers till 9. After printing 9, what happens? I value becomes 10. When I value becomes 10, the condition becomes false and we just go out of the loop. Another important point, guys, remember that, let me just go back to the slides for a bit. So what we just saw in the slides, these two sections, right, that you see over here, the initialization section, just a minute, initialization section and the updation section, they can have multiple statements separated by commas. What I mean by that is, basically you can have multiple initialization variables like separated by commas, you can have that, and basically you can also have multiple updation statements, so like I++ comma J++. Okay, we are going to see an example right now, so don't worry about that. I just wanted to point out that important fact in this slide right now. Okay, now let us see an example of a infinite loop in infinite loop in for loop. Sorry, I'm just fumbling a little bit. So let us see an example about the infinite loop in for loop, and this can be a question in the exam, and you may see this kind of question in the exam. So we are going to see 5 examples, not of the infinite loop. Infinite loop is actually one of the examples, one of the 5 examples. So this is how an infinite loop looks in for loop, right? Let us see that. So you go like this: for, just leave everything blank because everything is optional, okay, in a for loop. The initialization, the boolean and the updation statement is optional, but you should always have a condition statement over here so that you do not fall into an infinite loop. So we go inside this for loop, and there is a system.out.println statement which says hello world. Hello world. What do you think will happen in this case? We don't have a condition, right? Don't have a updation statement. Initialization, just leave it. We don't have anything over here. So this loop may actually, you will think that it will throw an compiler error. When we look at it, as I've already told you that these are optional, now you know that okay, we can write a for loop like this. But if you didn't know that thing, then you will think that this will throw a compiler error. But it will compile well and it will also run well. The thing is, it will just keep on executing this hello world statement again and again. So it will result in an infinite loop. So remember this kind of structure, you may see it in the exam, and don't think that it will throw a compiler error. Okay, so that was an example of the infinite loop in for. Now let us see the second example that I was talking about, right? Let us see that. Okay, so let us see this example, guys. This is the second example of a for loop question that you may get in the exam. One was the infinite loop statement. This one is adding multiple terms to the for statement. So if you see in this case, the code demonstrates 3 variations of the for loop that you may have not seen till now, and it looks kind of complicated, but it's very easy. First, you can declare a variable such as x in this example before the loop begins over here. We have declared that over there, and use it after it completes, like we have displayed it over here, right? Second, your initialization block, the boolean expression and the update statement can include extra variables that may not reference each other. As I told you, right, your initialization block, this block, and your updation block can have multiple statements and they can be separated by commas. Similarly, you can have this kind of boolean expression also. Okay, for example, in this case, z is defined in the initialization block and is never used, and that is fine. Finally, the update statement can modify multiple variables, right? This code will print the following when executed, right? Let us see the output in this case. It will print 0, 1, 2, 3 and 4. If you see this case, then it is how it is printed, because we are just printing the value of y over here. Okay, and we are checking if x is less than 5 and y is less than 10. So as x reaches 5, this one becomes false, right? And as one of the it uses a AND logical operator, right? If one side is false, then basically the whole expression is false. So we are not going to evaluate this y anymore because of the short circuit nature. So as this is false, basically when x equals to 5, then basically we do not go further. So we are just going to print from 0 to 4 for the y value. That is why this is the output. Okay, so keep this example in mind when we look at the next 3 examples, and we are going to see that none of those examples will compile, but in this case this example compiled, right, and we got this output. So make sure you don't get confused with the structure of the for loop in the exam. It is really important. Now let us go back and see the other examples. Now let's see this example, guys. In this particular example, what we see is this example kind of looks similar to the previous one, so you can just rewind the video and see the previous example, but it doesn't compile. And where it doesn't compile, basically doesn't compile over here, doesn't compile. Now let us understand why. Because of the initialization block. This one is the initialization block, right? So this, because of this initialization block, the difference is that x is repeated in the initialization block after already being declared before the loop. So as you can see, it has already been declared over here, but we are doing it again over here, right, resulting in the compiling resulting in the compilation error, because the compiler thinks that it is a duplicate variable declaration, because it thinks that you have already declared a int x. Now you are trying to declare a long x over here, because if you remember in our variables chapter, we have seen that we can use comma separated values to declare new variables, right? We can do like this thing. But how can we fix this scenario? Can we fix this scenario? Yes, obviously we can fix this scenario. How can we fix this scenario? Let us see. I'm going to use a green pen to fix this scenario. So you can do something like this. You can do int x equals to 0, and you can do a long y equals to 10, and then you can just say for, you can just say y equals to 0, and then you can just say x equals to 4, and then you can just keep whatever was as it is, and it will execute fine, because here we are just executing or declaring it once, right, and we are not redeclaring it over here. So that's why there is no errors in this case. So that was all about this example. Let us see another example, the example number 4, right? Okay guys, now let us see examples number 4 and 5. So basically, if you see this particular example, this says using incompatible data types in the initialization block. What is happening over here? This example is also kind of looks like our second example, right? Same thing, same kind of stuff we are doing, but like the third example, it will not compile, and where it will not compile, it will not compile at this point. So doesn't compile. And why it will not compile? But this this time, like unlike the third example, this will be for a different reason. The variables in the initialization block must all be of the same type, right? In the first example, if you remember, y and z were both long, so the code compiled without any issues. But in this example, they are having different types. So this is a long type, this is an integer x type, right? So these are of different types, so the code will not compile. So that is why it is saying doesn't compile over here. If you want to fix this, then basically change it, both of these to int or both of these to long, then it will work. Talking about the fifth example, it is already have been discussed this thing. We are trying to access a local variable which is local to the for loop, outside of the for loop. So this here it will doesn't compile, because we are trying to access x, which is local variable, to this scope, which is the scope of this for variable. So these are the variations of 5 examples, right, which you can face the questions in the exam. Obviously you may face some other kind of scenarios also, but these are the most basic scenarios. I think you will get the questions like 80% of the questions with just some variations on these examples. Okay, so make sure you have a keen eye on to what is happening in the for loop, because that's their favorite part to trick the students in the exam. Okay, let us see another kind of loop right now. Okay, now let us see this kind of loop which is known as the for each loop, right? Let us switch back to this here. So in this for each loop, what happened is that starting with Java 5, Java developers have had a new type of enhanced for loop at their disposal, okay, and one specifically designed for iterating over arrays and collection objects. So it is for arrays and collections. Now you don't know about collections or arrays as of now, we have not discussed it right now, but I'm going to show you some examples which will just throw some light on the for each statement. Okay, okay, this is the for each statement, my bad. So this is the for each statement. So as I've told you, it's for arrays and collections. So it's an enhanced kind of a for statement. Okay, now let us try to understand what this particular syntax does in this case. So in this particular syntax that you see over here, we have a collection name. So basically this can be an array, 0, 1, 2, 3, 4, 5. For example, this is an array. And here we have a single instance of a collection. So basically if this is an integer array, so a single instance of this particular collection will also be an integer. So the data type will also be an integer. And it is the variable name. So what will happen at each point in the iteration, one element of the particular array starting from the first element will be stored inside this instance. So at a particular point of time, for example, at the first iteration we will be having this particular element, at the second iteration we will be having this element, third iteration we will be having this element inside this instance. So we can do whatever we want with that particular element inside the body of the for loop. Okay, so it will be, this will be the entire collection, and this will be a single element of that collection at a particular iteration, right? So at the starting from the first element, it's not that we are going to start with a random element and we are going to iterate from that point. We are going to start from the first element, and basically we will be having access to all the elements of the collection. That's all there is to discuss about the for each statement. Now let us discuss some examples. You understood the logic, right? The syntax. Let us understand with some examples. Now let me go back to my IDE, and here let me write some examples. For example, let us write this code which says, let me think, final string. This will be an array. Don't worry about the syntax of the array. So just understand that arrays are just a collection of elements. Basically I'm creating a collection of elements as of now, which is an array. So names equals to, so it will be a string array. It means that it will collect multiple string values, equals to new string. And we are just, so we created an array with 3 elements. So here I created a array, a string array to be precise, string array with 3 elements, because we have specified the size as 3. We are going to learn this in depth later on, so don't worry about the syntax right now. Let us keep some data inside it. Name of 0 equals to, for example, Lisa. Names of 1 equals to, for example, Kevin, and for example names of 2. So basically we are just inputting the elements inside our array as of now. Roger, right? So we have 3 elements, as we have discussed, 3 names to be precise inside this thing. Now let us use the for each loop. So the for each loop, if you remember the syntax, for, then data type and single instance name. So the data type of any instance inside this particular array is string, right? Because every element is of string type, and arrays in Java are homogeneous. So obviously each element in your array will be of the same type. So string, single name, and colon the entire collection, which is names, right? And then we are just going to say sysout, or we can just going to use the print over here. We're going to say name plus comma and then space. Now let us execute this code. So you can see Lisa, Kevin, Roger. So this particular instance or this variable has access to one element at each iteration. In the first iteration, it has the access to Lisa. In the second iteration, Kevin is stored in here, and in the third iteration Roger is stored over here. That is why we are being able to access all the elements at this particular point, right? Now let us see another example. Now I'm going to use a collection framework, right? I'm going to use a collection framework. So I'm just going to say, don't worry about collection framework also. This is just a collection of data types as a framework in Java, right? I'm going to discuss this later on. So I'm going to create a list of string values, right? And I'm going to say equals to new array list. So I have created an array list instance, and let us add some elements into my array list. I'm just going to say values dot add. Let's add the same names, right? So Lisa. I'm just going to copy paste this 2 more times. Toy. Here we have Kevin with a capital K, and then we have Roger with a capital R. Now let us write the for each loop over here. Very easy to understand. So for example, for single instance, which is string value, whatever name you want to give, you can give, and the entire collection names, which is values, and then just sys out. Let us copy this print statement from here, and over here let us give us empty println statement over here, so we can go to the next line. Here I'm just going to say value, and then that's it. Let us see the output now. Here you can see that we are getting the same output over here, right? So the particular thing, so always remember that the left hand side we have a single instance of the particular collection. So single element of the collection we have in the left hand side. Sometimes the exam may play tricks based on this particular rule. Let us see the example where the exam may play tricks on you. Now it can say string names 1 equals to, for example, equals to Lisa, okay, and then we can they can give you this example which says for string name, and here names 1. But if you see in this case, it doesn't compile, right? Because this is not a collection, and obviously this is a single instance of a collection, but as this is not a collection, this will throw an error. That is why it doesn't compile. So this is one instance where you can get confused in this case. Okay. Now let us see another example where there will be a compilation error. So this is one example. Let us comment this out, so it will not break our program. So let us see another example right now. String names equals to new string, and for example 3, and okay, we already have the names, right? So let's say names 1, or let's take names 2, right? So we have this thing, and let's say for example for int name and then names, and if I try to do something over here, still it doesn't compile. Why? As I've told you, right, all the elements in a particular array are homogeneous. It means that if the array has been declared as a string array, then all the elements inside the array will be string. But in this case, the single element that we are accessing on the left hand side is an integer, while the array is of string type. So it will not compile in this case, and don't get confused in this particular scenario. Okay. Now let us compare for and for each loop once. Let me just comment this out, and let us compare the for and for each loops. So guys, let us see the for versus for each, right? Let us see when we can use for and when we can use for each. Okay. So since for and for each both use the same keyword, you might be wondering how they are related. While this discussion is out of scope for the exam, it is not required, but let's take a moment to explore how for each loops are converted to for loops by the compiler. Okay, because they're by default converted to for loops only. So when for each was introduced in Java 5, right, it was added as a compile time enhancement. Okay, it was added as a compile time enhancement. So this means that Java actually converts the for each loop into a standard for loop during the compilation. For example, let us take this particular example, right? Let us write this thing for string name, right, and colon names, right? This is the thing, and then we have a system.out.println statement, and we have some, so we are displaying the name, for example, over here, right? Now assuming names in the array of string, as we saw in the first example, here are the two loops equivalent, right? So this is the particular first loop. Let us see the for loop equivalent of this thing. Okay, let us see the for loop. So the for loop will go like this: for int I equals to 0, I less than names dot length, and then I plus plus. So this example we saw last time, right, in our ID. So we are just seeing the equivalent for loop over here, names dot length over here, and then I plus plus, and then string name equals to names of I. Right, this is how you access an element in a particular array. So storing that element in the name, right? This is a single you can compare it to a single instance or single element over here. So that is what is happening over here, and then we are just printing name. This is how it is being converted at the compile time. That is why it is a compile time enhancement. So basically, when you are extracting this name is actually this name in your for each loop. So this thing actually happens over here, and then we are displaying, and then we are displaying the name over here, right? Because with this common for loop, right, this is for and this is for each, right? In this common for loop, we actually have the indexes, we have the access to the indexes of the array, and using the indexes we are getting the element, right? Similar thing happens in the background with the for each loop, and we are getting that particular element. We are going to see more on arrays later on, so don't get confused, right? Okay, so if you remember, if you notice in our example, if you see this particular example that we saw, there is an extra this comma printed at the end, right? There was an extra comma printed at the end of the list. While the for each statement is convenient for working with lists in many cases, it does hide the access to the loop interior variable. Now, if we wanted to print only the comma between the names, we could convert the example into a standard for loop, and we can have this comma, gone in case of a normal for loop. If we implement it using a normal for loop, we will have more control so that we can exclude this comma at the end. But in the case of a for each loop, it is not possible. That's what I mean. Let us see an example in this case. We already have the names variable, array over here, right? Now let us implement that particular printing logic using a normal for loop. Let me go back down over here. Let me do this thing. For int I equals to 0, right? I less than names dot size, names dot length, that is an array. So you can get the length of an array using names dot length, and then you can just say I plus plus. You can just say string, here the same thing, string name equals to names of I. You can also use the array list that I have created, that is names 1, I think, somewhere over here or so values, that was values. You can use that values also, but I'm using the names array. So we got this. So if I is greater than 0, then let's write some logic over here. We print a comma, right? So then we print the name, right? Now let us see the output of this particular code in this particular scenario. Okay, I made a mistake over here. Print. Let us have a next line before this printing. Now See here in this case, when I implemented this using this particular logic, using the normal for loop, we do not have an comma at the end, because we had the access to the index. What is happening over here? It is common to use a standard for loop over a for each loop if comparing multiple elements in a loop within a single iteration. So in this case, what we are doing, basically when I value is greater than 0, it means that if when the index goes over 0, because for the first, before the first name, we do not want to print the particular comma. When I goes greater than 0, and it means that we have already printed the first name, because when I equals to 1, for I equals to 1, the element is Kevin, and before Kevin we need to have a comma. So that is why the comma gets printed over here, right? And then we print the name. So after the comma, when I plus plus happens, so I equals to 1, we first print the comma over here, and then we print the name, which is Kevin. And then before Kevin also, what happens? Roger. For Roger, I equals to 2, so it is still greater than 0, and we print the comma first, and then we print Roger. But when I becomes 3, what happens in this case? This particular condition doesn't even evaluate, because it becomes false. Because what is the length of the array in this case? Length of the array is, or the size of the array is 3, and when I equals to 3, then this condition becomes false. 3 is not less than the length, so it doesn't even go inside this array, right? So here we wrote some logic which helped us to exclude this comma from the end. So you can just say that sometimes when you need more control, you go for the for loop instead of the for each loop, right? And it is also common to use a standard for loop over a for each loop if comparing multiple elements in a loop, right, as I've already told you, within a single iteration. Now let us see this example, and let us see what I mean by that. So let us go down in this here, and let us write the example. For example, int values 1 equals to, because we have already defined the values, right? So values 1 equals to new int and 3. Here let us say values of 0 equals to 10, values of 1 equals to new integer 5. Don't worry, this is just a wrapper class. Okay, values 1, this is values 1, right? And then for example, values 1 of 2 equals to 15, right? Let's take this. So 3 elements, as we have discussed, is discussed that we will have 3 elements over here, so size is 3. Let's go down and let us do some other stuff. So for int I equals to 1, let's say, and I less than values 1, right? It is values 1 dot length, right? And then I plus plus. So this is the loop that I have. I can just, for example, I want to do sys out values of I, values 1 of I minus values 1 of I minus 1. So here what we are doing is, we are actually, so for example, what is actually happening here is that, let me just remove all this thing. Oh my god. So let us create some space to understand what is happening. So we have 3 elements in our array, right? We have 3 elements in our array, which are basically, not, I need the black, which are 10, 5 and 15. 10, 5 and 15. So as I told you, array index starts from 0, 1 to 0, and we are starting from 1, right? We are starting from 1, and we are comparing the current element, which is this one, with the previous element, which is this one, right? So this is I and this is I minus 1, right? This is what we are doing. So basically this is possible to do because we are using a for loop over here, and we have the access to the indexes of the particular array. But if we use a for each loop, we just have the access to that particular element. We do not have the access to the index, so we cannot go back and forth, or we cannot compare one element to another element in that particular array, right? So that is where you can understand now that if you want more control, you can just use the particular for loop, but if you want an easy way to implement or just to display or just for some common use case for your collection, if you want to use a loop, then you can go for the for each loop. Now if I just execute this loop, we are getting 10 over here. Okay, -5 is printed over here. Okay, so let me just keep a ln statement so that we go to the next line. So -5 and 10. Okay, because first what happens, first what happens, 5 minus 10 happens, because this is I and this is I minus 1. So 5 minus 10 is -5. Then I goes to this place, I goes to this place. Now this is I and this is I minus 1. So 15 minus 5, 15 minus 5, which is 10. So we get -5 and 10 as the outputs. We are going to discuss all the array topics in details later on in the array chapter. Don't worry about it right now. Okay, now that was all about loops, guys. We discussed a lot about while, do while, and for loop and for each. That's the enhanced for loop.